Right, well, right. Good evening, everybody, and thank you very much for sticking with us tonight. It slightly feels as if we're doomed in this lecture, but hopefully not, and hopefully you will enjoy this presentation today. I know that some of you will have, if not all of you, were with us last week, and that was really quite unfortunate, but I'm more than happy to be back today. So, as some people may not have been with us last week, just to really start off by saying who I am and what I do. So I am a landscape architect in private practice, and I'm head of practice for our organisation, which is Illman Young Landscape Design. I've been involved in sustainable drainage for quite a very long time now. I actually think it's best part of 20 years or so. And interestingly, and if we get time, I was actually sitting in a DEFRA committee meeting today talking about the potential changes to the legislation in sustainable drainage. So I think those of us who are interested felt that we weren't sure what was happening about it and weren't quite concerned about what steps the new government might take, having been in office for a little while now. But things were sounding positive today. And if people are interested, maybe we come back to that later. Anyway, what do I do? Well, actually, we get involved in landscapes for almost anything. And so, yes, fairly straightforward stuff it might seem, master planning and site design generally. But other sorts of things we do, particularly me, I do a lot of report writing, which is called landscape appraisals and environmental assessments to look at development and see where it's appropriate to do development and how that might sit, bearing in mind the design of the site, the water management, and the general landscape context. But in which case, on some projects, we will take them through from the initial site inspection right the way through to design and completion. But obviously what we do is what the client asks us to do. And as I say, that can be many and varied. But in what we do, I think our ambition really is to try to create landscapes that are attractive, sustainable and practical. And also really to see how if we can be a little bit innovative as well. So as I say, I've been involved quite a long time. I'm in Cheltenham here in Gloucestershire, and have been here really ever since I came up to university and then ended up staying. And as part of wanting to extend the work we did in the practice, I became interested in water management, set up a 2-year research project with the university here to actually look at it in more depth on the basis that we weren't doing anything with water in the landscape, rainwater in particular, and it just seemed a waste of time that we were always finding ways of trying to dispose of it. And that just seemed a bit of a waste on the basis that it could be something that was an attractive feature within a site. And why didn't we think about that? And when we looked into that further, there was quite a group of us, sort of smallish group who were equally interested when we first heard about things called SuDS, which originated in America, a place at Portland in Oregon. And it was a landscape architect who came up with the concept, and he did so because he wanted to do something with the water from his garden shed. So we're all thinking much the same way in that respect. So we want to, I think the point about it is that dealing with water today is really important. So yes, it's a nice feature and we can work with it, but actually, when we're looking at climate change and the problems that there are in terms of water, it's invariably there's either too much or not enough. But it's not just about water, because the fact that we have issues with water affects so many other things. And we've seen the issues in America recently in terms of fires and how they're struggling to contain them with the amount of water that they've got. We understand the issues around sea level rise and the effects that these things have on our ecosystems. And actually, not only that, but the effects on people with the problems that we have. So water is a key part of some of these issues, but it can also help to solve some of the problems too. And the concern about water goes back quite a long way. I mentioned this last week. This slide is one that was done by, it doesn't actually say the name of the person, I can't remember who his name was, but he was chair of one of the government committees. And in this assessment, that in terms of that water group there, the biggest and most risky thing that they saw was top left, the development and surface water flood risk. So this issue around flood risk has been around for a long time. This one was from 2014, I think, and also the soil health and carbon sequestration. So, it's understood by those in power, if they bother to engage with it, that actually water management and what we do with our water is really essential. And if you look at the rest of this little slide, water comes up quite a few times on it. It really is a critical factor in those considerations. So, and I rather like this one. So this was from the Chief Executive of the Environment Agency, talking about the problem with leakage from pipes and the issues it has for water, talking about the jaws of death. Slight exaggeration, perhaps, but again, acknowledging the fact that water is a key factor in our lives and our everyday lives. And with population growth and climate change, these things become even more to the point. So when in the early days of starting looking at SuDS, there are lots of acronyms that could be used in terms of what it was all about. And water sensitive urban design is one that I think has always been quite a nice one to use, thinking about how we plan our towns and cities and actually consider water as part of that, or as a fundamental part of it, so that because we need to reduce the demand for potable water, we need to clean and recycle our grey water much better than we do, and there's no reason why we can't do that and reuse it on site in many industries. We also have the ability to manage and use black water with the right approach to it. And fundamental is the risk from flooding. And we've increasingly seen flooding happening in areas around the country, often in not major areas, but in specific areas, just depending on the climate and which way, the weather is going, really. But we also need to understand that these things are expensive when they go wrong. Flooding is a devastating thing to happen to anybody. But, water sensitive urban design as a concept really introduced people to the concept of SuDS and actually starting to think about how we integrate it within the built environment and the importance of doing this, as part of the design process. But this thinking was really seen as a bit of a step too far then, but it formed the basis of what we've been pressurizing for the last, as I say, 15 to 20 years. So this is just some information on this concept of water sensitive urban design. Again, this is started not in England, but we picked up on the tenets of that really quite, very rapidly. And looking at the concepts, I think if you look at this example, you can tell it's probably not here because we don't get these very nicely planted highways with lots of planting all along the sides of it. France do quite a good job with SuDS as well, but perhaps because we're slightly more limited in space, we're not doing it to quite the same extent. But there's lots we can do. So there's two principles to this then, is that you need to have water cycle management for a healthy environment. And that's got to not just support people, but it's also got to support the biodiversity, the wildlife around us. And water cycle considerations, if you're considering that throughout the design process, then you're more likely to achieve a successful outcome and something that then can be an attractive contribution to the urban environment. And there's lots of ways you can do it. I mean, how you design something is entirely a matter for you. It's just understanding the technology of the approach in how you design it that is really the thing that is the interesting challenge. So I think just understanding what the problems are in terms of, this sort of boomerang between floods and drought. We've not had so many of the droughts recently, but we've certainly had a few more of the floods. And, I think people do understand that we are having these, more extreme and prolonged rainfall events. And the problem with that is that historically our towns and villages and cities were located on rivers because that was their means of transport to actually, move things around the country. And therefore that puts them automatically into a slightly more vulnerable position. I mean, London itself still has issues about flooding, definitely, and the way that new development along the Thames is having to reflect that in its design. But we have water from other sources as well. So we've got groundwater, and obviously groundwater moves up and down through the soil, and that itself can cause flooding. Then we've got the coastal flooding, where we're seeing that when we get storms on the coast, that in some places that they are, having more and more severe effects. As you probably know, the country is tilting very slightly. So the east coast is sinking slightly, and the west coast is rising slightly, very, very slightly. But we're definitely seeing that there needs to be much greater protection, particularly on the east coast of England. And those sorts of things do make a change. And in those instances, you do have to think about what you save and what you protect and what has to be sacrificed. So that also is going to affect land management. Obviously, in coastal areas, that will be quite different. But generally, we need to think about that and the overlying flows that we can often get from agricultural land, which again can contribute to localized problems. But one of those is very much about development and the extent to which we have urban creep, the ongoing development, and no doubt we're going to see much more of that with the government, who are very keen on their ideas of creating new housing. We just need it to be done properly so that the water aspect of it doesn't become a problem in all of those new houses. Because actually our network has a limited capacity. And when they were designed, they were never designed for the type of rainfall events that we get now. And the statistic of 1 in 5 homes and businesses at risk is those types of statistics haven't really changed much in all the years that I've been involved in water management, because the issues it has got worse. So we do lots of retrofitting, we affect change and improve some areas, but other areas are then coming into the risk factor. And there's a massive, financial cost and social costs when you have flooding, and the reinstatement afterwards. So, we have development throughout a catchment, and really the problems that we have are many and varied, and it really just depends where you are, the types of problems that you're likely to encounter. So if we're upstream, where we may be in agricultural land, then overgrazing and poaching of the riverbanks by animals can cause significant problems. The fact that you need to consider how you plough the land, try to stop the flows downhill, how you're going to address land drainage, and actually deforestation in itself clearly can cause those problems of, again, the soils getting saturated and not holding back the water. Downstream, we then get that siltation from upstream that's then flowing down and causing problems further down the systems, and similarly flood flows that may be coming downstream from events upstream. And coming from the other end is where we get coastal surges and therefore the erosion that causes. So, the problems are, as I say, many and varied, and perhaps in unexpected ways at times if you're not aware of the consequences of some of these things. And of course, when we get into the urban area, now we're densifying our urban environment, but there's this massive lack and problem of capacity in the network for pipe drainage. So all the time that we're adding more housing to that, we're also encountering problems of the fact of, can you connect people into the networks to enable them to live a normal life there? So lots and lots of causes, and equally a wide range of solutions to deal with the problems that arise. And this was just a little chart that was done on behalf of the Welsh Assembly government, which actually said, you've got to think about water and how you're using it. And if you're not managing it in terms of flooding, then the problem is only going to get significantly worse. And to improve it, it's not just about controlling future flows of water from development. We've got to not only control those future development flows, but we've actually got to change the existing environment that we live in. And that's why retrofitting of SuDS is so important, because the reason we use SuDS in the main, or we have in the past up till now, has been to rectify problems that exist. Now we want to see development integrating it all the time, which is in a way of trying to reduce the problems for the future, but also to ensure that when we put new housing into a scheme, that we're not making any existing problems worse. So that aspect of it is a really important thing to understand. So the sorts of things that, again, that you can do about planting is a big one, and land management, as I said. So planting these field margins, looking at how the stock is allowed to work on the land. Leaky dams, we see lots of more innovative things happening now, like where, looks a bit messy there, but stopping the water from flowing so quickly down the hills is an important thing. Looking at how we're developing, we haven't developed a decent reservoir for years. They're talking about doing some again now, which is quite important. We stopped building reservoirs quite some time ago. The issues around peat, by actually letting water be held back by peat on the upper slopes where that's relevant, and actually getting rid of some of our modern drainage systems so that we can hold that water back. And downstream, we need to do dredging, and we need these alleviation schemes because, as we know, water flows downhill by the fastest possible route. And where does it accumulate? Downstream. And at the same time, coastal defences. And there's work happening in things like coastal realignment and what's called managed retreat, which is accepting that we know something can't be saved forever. And if we deal it properly, it can help as part of our defences, but we can no longer perhaps manage that land or indeed live on it. And urban areas, obviously, there's a whole range of responses there that we need to address. And so a nice example here, this was the Moors for the Future project, and this was the reinstatement of peat moss, recreating peat moss areas, which they did over a 4-year period. And that was done in some degraded industrial land, which was causing erosion and pollution. But by introducing the peat moss and allowing that to develop naturally, then it holds up to 20 times its weight in water. And that had a massive effect in preventing downstream flooding just by using natural resources. And equally important is considering climate change is that use of peat moss actually prevents erosion of the peat and acts as a carbon sink. So it's doing several jobs all at once. And in terms of water quality, it reduces the amount of peat particles in the water because it's not being washed out, it's being held back within the moss. And therefore, it's reducing the coloration of the water, because if you've ever visited somewhere where you get peaty waters, then it looks a slightly brownish colour. And clearly that's not socially acceptable to people in their houses. So that's quite expensive chemical treatment to sort it out. So the moss is doing a great job in terms of the practical effects, but it's also then encouraging a wider range of species there in terms of biodiversity. So something very simple. It's had a massively effective change to the watercourses here and managing the water and and safety from that point of view as well. So an excellent example of what we can do when we think about the problem and start to think laterally about it. So in terms of sort of general issues, in terms of looking at landscape scale flood management, it's really had not much attention by the public because people don't tend to talk about it as a general thing. Obviously, if there's some form of disaster, then it's all over the press. But there's quite a lot of work going on, just all around the country in different ways, because what you do in any one place is very much about what's in the locality, the nature of the housing, the nature of the situation, and the way in which one chooses to address it. But it's a great opportunity for a more creative design approach, and definitely has been used as a part of regeneration projects to just generally upgrade and improve areas. But at the same time, because we're wanting to look at the multiple benefits, then looking at habitat creation and those sorts of things just adds that bit extra to everything that can be done. But if you're going to do that in the public environment, they've got to be robust schemes, and they've really got to be socially acceptable to the people that are there. So the work that's done, does need to be explained carefully to the people that live there, so that they understand why we wish to make change and what those changes will deliver. Because at the moment, the risk to life is really quite underestimated in terms of flooding in particular, and also the long-term impacts on land. So, and the point about it is that if you live in one of these areas, whatever is done there, those people have to live with those schemes, 365 days of the year. So getting it right is a very, very important part of what we try to do. So there's two ways that you can work in terms of coastal change, and they're called hold the line and retreat the line, which is pretty basic, and it really does what it says on the tin. So if you're holding the line, you're probably going to do that because you're living in you're working in a developed area, and we're trying to basically protect the houses and the people who are already living there. And there's lots of examples of, we try to make them more creative. So with these hard defences, and actually make them part of perhaps seaside walks or promenades, whatever, but to actually do it in a way that is socially acceptable, but actually is massively practical and probably quite highly engineered. And they're absolutely key to get our infrastructure right wherever they are done. But if we can't do that, then it may be that we'll have to retreat the line, in which case that needs to be managed and thought about, and the realignment created positively rather than just letting nature happen. We do let nature happen, but we also manage the land to try to make sure that it does it within specific parameters, I should say. And obviously this is something that generally happens in rural areas. It's not going to happen around our towns. But that is about working with natural processes and allowing them to happen in a way that is positive. And so, if we're doing either of these, then it's usually going to be in an urban environment. And if you're doing it at the seaside, then there's all the other fun things to play with about the nostalgia about being at the sea. But these can be major regeneration opportunities. And in fact, there was funded work that was going around coastal areas a couple of years, well, not a couple of years ago, about 10 years ago, doing these sorts of projects funded by the local authorities or government money to do so. And it has been very, very effective. And, integrating with the towns and actually encouraging them to do local redevelopment as well, but still working with the local character and its urban design. But they've got to be bussed, they've got to be maintained. But as I said, they do have to integrate with the urban infrastructure. And because many, many coastal towns do experience this surface water flooding or flooding from the sea. This was quite a nice example some years ago, and this was where they undertook what's called managed realignment. This was the Grantham realignment and brine wells. By allowing a large area of land to flood, it stopped flooding elsewhere around the town where people were living. So it was a sort of a balancing act in a way between building defences for the developed area, but at the same time allowing and encouraging water in other areas. And a significant site, but had made a massive difference in terms of natural regeneration. And it happened incredibly quickly. Once the land had all been regraded and water was allowed to flow through it, you can see the flow paths quite easily in the picture on the left. But the natural regeneration that happened was really within a couple of years. And habitat recreation, so it brought a lot of good, and it was good for the birds and all sorts of things. So lots of positive outcomes, which is clearly what one is trying to achieve. So really all we're saying is that, when you're looking at water management, then really it's about trying to do an integrated approach to what you do. So from the policies that you've got, the work that you choose to do, but also understanding that there are times when you can't do it, and then you just have to try to make properties as resilient as you possibly can. And photographs like this are just infinitely depressing and terrible for the people that have to experience them. So and just another little example, this was in the Derwent Valley, and again a development on the side of the river, developed because of transport and the energy and those sorts of things. So very intensive land use, how to remodel the towns and the cities. And for some of these, the defences can be things that are temporary. And in this example, that's part of what they did. So and they built these riverside walks and raised up the banks and put in walls to hold the water back. But these were also gated, and they could close those gates as and when they needed to if the river was in spate. But encouraging people to be creative about how we can actually stop this flooding, but actually make improve the environment, but also make it safe. So and they did it here as well, because it's a World Heritage Site. So it was all part of a revisioning of the city centre. And, again, as you see, when we have a decent sized city, we're going to be having a river or a stream going through the middle of it. But, and it's challenging, because you're doing this where the area has been built up for many years. And clearly there can be a resistance to the change that's necessary. And this does involve, and has done, the removal of buildings to enable the water to flow and be managed properly, but also then, providing new housing for other people elsewhere, because it's the greater good that has to be delivered in these, and and sustainable drainage is very much a part of that. Now, this one is a lovely project, and if any of you ever go up to Sheffield, you'll know what I'm going to be talking about. But this is a project that was done, that was called Greater Green, and it started, there you go. So the first phases 1 to 3, there we go, February 2015. So we're now talking, blimey, 10 years ago to when this was first started. And the landscape architect department at the council in Sheffield wanted to do something with the centre of the city due to changes that had happened there. So what happened, they put in a big new ring road around part of Sheffield. And what that did is it made some of the roads relatively redundant. So whilst they still took some local traffic, they were not part of the major roadscape through this part of Sheffield. And it was like, well, what do we do with it? Because people are living and working in this area, but, this is just a sea of tarmac. well, with a few trees down the side. So look at this slide and look at the houses at the end that you can see at the end. And I can then show you how it's been changed, because it was really quite radical and excellently done. And that's what it looked like. So that building that you can see between the bus and the trees in the middle is the one we were looking down the road at just now. And that was this was relatively soon after it was planted at the Greater Green Project. And since then, they have now taken much bigger areas around the city and taken this approach to this is sustainable drainage. So it might look like lots of nice tree and shrub and wildflower planting, but actually this is a water management feature, but well integrated into the urban environment. So you can see the trees there. So there's looks like some birches there, you know, young trees growing up, and they still got the protective fencing around them. Still got buses going down the side, and you get the odd cyclists coming through the middle. But it's really interesting as well how they've planted it, because they've planted it with a big mix of different plants, and not as you might in a conventional planting scheme, say for a garden, but with lots of things mixed up together. Because if nothing else, they didn't really know how it would work. So it was a big experiment that's worked extremely well. And it looks like you can see that you've got soil joining to the paving, but then this soil has water capacity, and there are pipes underneath it that take the water that, when it rains, that comes through here and drains it down, but takes it slowly elsewhere to where it can be discharged. But really nicely done. So real big mix of planting, and they have an interesting approach to their management of it, because there's a lot of herbaceous plants and soft planting in here, as you can see. And I don't know if they still do it now, but I think they do. And in February, they come around with a chainsaw and they chop it all down to more or less ground level, other than some of the permanent woody bushes and things that they might have. They're obviously not the trees either. But all of this soft stuff gets completely macheted each year, and then it grows back again. And you know, and therefore there's always something of interest to see, regardless of the time of year. And that approach has actually been taken up by quite a number of other people who also taken this approach, but nothing on the scale of what has been done in Sheffield. And so this was one of the sites that that I saw before it had been. It was a big redevelopment program here at this part, just off the, you know, around the corner from where those photographs were taken. And so if you see the glazed floors to the building on the right hand side, this was it before it was planted. And that was it after it had been landscaped and planted. And what a fantastic difference that made to the environment there up in Sheffield. So, and I say they've continued to take this approach around the city, but every bit of it's slightly different, but very, very nicely done. But this is all about water management, and the planting and everything else is the real bonus that you get out of it. So going back to how we then have to deal with this and how we have to get it integrated, because it is a problem that we still have, is it needs to come through our planning system and through policy. And we just are not there yet. So 2015, we had the Flood and Water Management Act, and then it took ages to get most of it implemented. And we were well on track to actually getting it set up comprehensively in this country. And then at the last minute, they pulled the plug on it and didn't make using sustainable drainage mandatory. They made it so that it was optional. And that has been a bugbear for many, 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 many years. And as I say, I was in the DEFRA steering group today, and we're still talking about the same old thing, and it's 10 years down the track. But they do seem to have a plan now. It hasn't come out from government yet. But for once, we had MHCLG and DEFRA together in the same meeting, talking with the steering group. And I think we've got a decent chance, if things go well, that we may get that policy formalised properly sometime in the next probably 18 months. But if you haven't got policy coming from government, it makes everything else so much more difficult. We can get it at the regional or local level, but it doesn't have the strength and authority that it does if it starts by being something that is government led. But there's plenty of good work that's been done regardless of that. So looking at regeneration and urban rethinking, particularly around flooding, has been a useful thing. But we've got to think about, because what we're looking for is this combination of water management, but it's quality, quantity, amenity, and biodiversity. And all of those things have gradually become much more important. And biodiversity in particular has. So if we want to achieve the targets that are being set, then again, SuDS is going to help us by delivering that aspect of it very effectively. So there's lots of policies in terms of what's called SPDs and SWMPs. Those are just acronyms for just getting people to deliver water management in different ways, and getting that advice through the planning system to actually do that. So how do we do it and where do we do it? Well, actually, with new build, I think it's criminal if it's not properly integrated within any new development, but we're not there yet. Regeneration is obviously important, but retrofitting is therefore the sticking plaster that we put on it. And this is a retrofit scheme. This is actually out in America, but something, a delightful addition to the urban landscape. But we also can do community-led planning. So neighbourhood plans can be very useful in terms of small-scale redevelopment and retrofitting. And particularly community-based approaches, they are very, very effective. But what we need to actually do it is to have some leadership in it, and we're not quite there yet, but I am hopeful. So one of the better ways to do it actually is through partnerships. And you do have to do this, because if you want to retrofit, you've got to work in partnership with the local authority, with the water companies, with the people that live in the area, and those who are managing, the politics and the finances in the local areas as well. So, communication is absolutely fundamental, and working in partnership, because it's the most cost-effective way to do so. So this is an approach which is called the catchment-based approach, and it has become quite well established and quite useful in terms of new initiatives. And that is by bringing together a lot of partners from different organisations locally in their own environments, and that's from the rural edge into the urban environment, and looking at the changes that can be made to actually manage water within an area, because the area that floods may just be receiving water from that's been generated elsewhere. So it's not just about where the flooding is happening, it's where that flood water is coming from and where it needed to go, and actually understanding those networks, because water obviously creates these massive networks, and particularly when it's in spades. So getting these people together, whether they're commercial organisations or whatever they are, pulling that together as a community-based approach is a really effective way of delivering things. And so they set up a series of demonstration projects, of which this was one, to actually show what could be done and the difference that could be made by some relatively simple interventions, but what a big effect that they could have. But it was also one about collaboration, and also getting people to be involved, financially as well as practically, and supportive of the whole approach. So what are SuDS? We'll get to this later, but I think the point about this is, this is the mantra. The sustainable drainage systems are a sequence of planted and constructed features designed to slow down rainwater runoff by mimicking natural drainage. So you've got to get to know your suds, and we'll look at Let's Get Nibbling, hopefully, if we have enough time. So I don't know if people want to have a little 5-minute break, 10-minute break now, or whether I should plan. So, Catherine, what's your view on that?
I think given that we started late, we probably should plough on if that's all right, Sue.
Yeah, more than happy to plough on. I'm good at ploughing, definitely good at ploughing.
Excellent, thank you.
Right, so we're doing all right, I think, aren't we? We're not doing too badly. So this is just to say these are what we call the SuDS Bibles, the SuDS manual and the guidance on the construction of SuDS. And these are just documents, just mention it in passing, that are produced by an organisation called CIRIA, the Construction Industry Research and Information Association. And they've published, these tomes. The SuDS manual is 1,000 pages, and it tells you everything you might ever wish to know about how to design and build SuDS. But the detailed one is Guidance on the Construction of SuDS, which was written by a chap called Steve Wilson, who's a hydrological and geotechnical engineer, and myself. And these are the two books that everybody has to consult. Soon to be going online for your delight and delectation. Well, this year, hopefully. So I think, so just really to explain some of the sort of more technical side of things, I've talked about quality, quantity, amenity, and biodiversity. And if we look at conventional drainage systems, then basically it's all about quantity. You might get a bit of water quality improvements, but probably not. Amenity, well, if it's gone down a pipe, it's not coming out and doing anything particularly interesting. And biodiversity, almost nothing at all. Whereas if you take the sustainable drainage approach, then you can get benefits out of all of these things. So what's what we call the 4 pillars of science, the way in which we control the quantity of water runoff in different ways, and how that enables us, therefore, to manage the quality of the runoff to prevent pollution. And then as a consequence of that, we can create better places for people and better places for nature. So that coming together is the fundamental part of our SuDS approach. And it's not that difficult to do. And so the benefits that it can deliver, well, clearly, if we're introducing green spaces into the urban environment, then hopefully we are designing and delivering attractive, healthy places. But they also can be made to be, relevant to the locality, picking up on local themes and interests. They are inherently resilient in the way that they're designed and constructed. So, that is their job. And they also can allow you, depending on what you do, to reuse rainwater and do so effectively. It will absolutely, beyond a doubt, enhance water quality. And that is because of the way that water will flow through the aggregates that are within some of the systems that we have. And that enables them to actually get rid of silts and sediments that may be held within that water, so that once it's run through SuDS, it comes out better quality than it goes in. And if you think about that for rainwater that's run off a highway, that highway water is full of oils in particular that have come from vehicles. Won't be so bad if we're all in electric vehicles, obviously. I won't be able to say that any longer. But the runoff, just by going through a series of wet-dry systems, can actually come out. Well, we did one project when we were doing the research side of it, and we went to a motorway service area, and we measured the quality of the water that was running off it was from the lorry park, and we measured the quality of that, and it went through the SuDS, it went through the various systems that have been put in place, and eventually, just behind the motorway service area buildings, it connected with a local stream. And when we measured the water quality in the water that had gone through the SuDS, having started in the lorry park, the water that went into the stream was cleaner than the water that was in the stream already. So that just demonstrates, it was astonishing that you could actually get water cleaner just by putting it through these vegetated, primarily grass, but vegetated systems, and coming out with water that had got rid of all of the oils and the other things that were flowing into it through having come through the lorry park. So, we can do that, so we can improve that water quality. Similarly, that's clearly then supports the aquatic environment, because we've improved the water quality for those in the aquatic environment, which is where the water invariably will end up. And that enables us, therefore, to create new habitats and networks, because SuDS works as a network in itself. So, those two come together really well, and therefore creating healthier environments, which hopefully is good for people. So I was just going to show you a scheme that we worked on, to just show you how we approach designing SuDS and how we integrate them into developments. This was a housing development that was proposed. And so not the first thing that we looked at. Clearly, we had to look at plenty of other ones, but in terms of water management, the first thing is, does it flood? And if it does flood, where does it flood? So then to understand that, we need to look at its topography. We also want to understand the local landscape character, so that anything that we design will hopefully fit within that character area. This one had a fairly minor but locally important historic context to two buildings that were remaining, that have been there for a couple of 100 years. And any visual issues arising from the development in terms of local sensitivities about developing land that was currently used for grazing. The trees that were on that site and the existing ecological resource, of which there were some, but not a huge amount. And then the things that were going to make that a nice place to live. So what we would call placemaking, and something that was an attractive environment, how that was accessed and the connections that it required to enable it to sit within the context of the existing housing area, and then actually creating some decent spaces for play and public open space for both the local residents and the people who will be coming in to actually get out into and enjoy. So this is the site area, and part of it, first thing we always do is have a look at what happens with the water. And you can see that whilst our site is the red line area, the water did flood through part of the site already, although the worst flooding was actually on the other side of the road. But this was something which we needed to acknowledge and understand and design for within the scheme. And we look back historically as to what had been on the site, going back to 1881 right through to 73 on the mapping, and how that had changed. And surprisingly, it hadn't changed as much as one might have thought. But it was important to understand the historic context, because if nothing else, that has resonance for the people who are living in that area. And then, starting to look at the different aspects of the existing area, and what was marginally less developed land and what was more developed land, and how it all came together, relating to the site itself. And I'm just trying to think what the little blue spots were for. I can't remember. I think that might have been to do with areas of particular interest, or it may have been to do with biodiversity. I can't remember now, to tell the truth. But then this is the site itself. So understanding that context, and understanding the trees that were there, those that were important, those in good condition, those that are really on their last legs, and relatively flat site. It did fall very gradually, but not very much. But it did have quite a pleasant character and formed something of a green oasis in quite a developed area. And they were still grazing part of it. And this looked at the quality of the trees that were left on site. And actually, there weren't that many on the site, but they certainly had a big effect on its landscape character. And then starting to look at how that site might be developed and what might be put where. And it was decided that any housing that was going to go there would only go on the south east side of it, which is where the grazing land was, and therefore the biodiversity or any other aspects in terms of its history were much less important than they were elsewhere. So you can see that there were trees in the area that is green. That's where the majority of the good quality trees were. And the ones that were within the housing area in the main were not particularly good quality. And then the blue area is the area that was prone to flooding. So clearly that was an area that needed to be avoided in terms of actually any proposed housing development. And so that led to a sort of rough conceptual plan as to how that site might be divided up into what we call land parcels, and what the network of connections might be. There was already a lane that went through the site, but it was gated and really only used by the farmers who were managing the land. But that offered an opportunity to provide new connections through the site, and particularly if the Illman scheme was developed. And then that started to look at some of the other issues about where the footpath networks might go, where they might connect into existing features, both within and beyond the site, taking them down to the pub, if nothing else, and a few other areas, and down the main road to the shops, and also where access to the school, the existing school, locally off-site might be. So looking at the connectivity there and how people might move around those areas, and then taking that further and looking at the next layer of things like where the footpath networks, where play facilities might be included, and the types of play facilities that might be provided. Because there's a requirement to provide specific areas of play depending on the number of dwellings that are to be built in any one area. And there's things called laps and leaps. A lap is a local area of play, whereas a leap is a locally equipped area of play, so a bigger facility. And again, how those might be located and that sort of thing. And then this part of it was then just looking at the type of development that might go there. So the blue one is the central boulevard going up through the site, which would have one type of character, what's called the park edge that went round the edges of it, and the centre part, which was obviously unsurprisingly called the central zone. And then water management had to come in pretty early on, because water was and is a factor on that site as to how we were going to manage the water that would be coming from. We've got agricultural land that is now going to become developed. Therefore, we're going to have a lot more runoff coming out of this land or flowing over this land, and how are we going to manage that so that it doesn't have any effect on either the people in these new houses or anything on any of the existing people living along the roads adjacent to it. And as part of a community consultation event, to actually start to take it to a human scale and to actually explain these things through creating sketches annotated to show both the widths of the roads, the cycle routes, the tree planting, and the SuDS integrating within the highways. And several of these. So this was looking at the central boulevard, and also looking at the types of housing that was going to be there, how the parking worked, the cycle tracks, and all of those sorts of things. And so we would, normally produce, particularly for a scheme of this size, quite a with the architects, quite a detailed amount of information to communicate to the public exactly what it might look like and what could be delivered. And I think the little plan there is really quite helpful, but you can see how spacious some of this was the central boulevard, how spacious that could be to, creating hopefully an attractive and pleasant environment for the new users, and other bits and bobs. This was the park edge, so this was adjacent to the main road to the southeast, and existing trees, number 2, as opposed to the new planting that would be carried out on the site. So this is very, I think, typical approach in terms of communication, and community engagement is a really important thing where new development's happening in existing communities. But the SuDS was really a very, very important part of this, because everybody knew that this land, in parts of it, were prone to flooding, and that they were concerned that it wouldn't make the flooding worse for them or introduce flooding into the area where there was none at present. So these were real concerns that needed to be satisfied as part of this consultation event. But we've got lots of them. And so really just showing the different types and perhaps more and more detail. And then we had a plan that showed how it all worked out in plan and connected into the houses and elsewhere. And that was the overall master plan for the site as a whole. So what you can see is that this was a really big site, but had a lot of sensitivities in terms of its history, the existing buildings retained, the farmland, and particularly the water, and to try to integrate those in a sensitive way and to provide the best environment for new people coming into the area or wanting first homes, but also to make sure that it sat comfortably within that context, and did all the necessary to make sure that it would be a safe and attractive environment, and that none of these houses would flood and that none of the neighbours would be affected by it. So let me just have a quick look at the time. Yes, we're fine. So I'm now going to go sort of slightly back to starters as a way, and this is the way that we used to teach SuDS when we all started, was to go right back to the beginning and talk about the hydrological cycle. But don't worry, it's not going to get too technical. But this is just to talk about what happens to water in nature, because we have to understand how water works in nature if we're going to manage it in our schemes. So in the natural environment, when it rains, precipitation, obviously rain falls on the plants and on the ground, and in that flow of going through that vegetation, some of it will infiltrate the ground, and if it's been raining for long enough, then some of it will flow as a surface flow across the ground, and that will keep flowing downstream until perhaps it meets a pond, or further downstream down the land it might meet a stream and then be in a water body that is conveyed elsewhere, perhaps to a river, and indeed even out to sea. And from those features, from that pond or from that stream, you will also get infiltration to a certain extent into the ground. And what you can do is get what's called interflow, which is where water will move sideways through land to get to lower levels as well, but that's not such a big deal. And then when it stops raining, you get something called evapotranspiration, which is the evaporation of the water off the plants back into the atmosphere. And that's what's known as the hydrological cycle. When we go to looking at SuDS, what we're doing is we're looking at that inspiration from nature. And in the design of what we do and the features that we design, we're trying to echo that natural system of drainage, but do so through these constructed features that we've got. So if we look back we've now got a house on this landscape, and they're going to have a water butt. So that water butt's going to collect water, and hopefully if it's used regularly enough to water the garden, then actually it has some value. Water buds that are full of water that never goes anywhere don't really do anything at all. And the roof runoff, what are we going to do with that? Well, that might come down and we might have permeable paving so that we can park the car on some permeable paving and enable that to slowly infiltrate into the ground. If we want to then perhaps take that water to flow down a slope, we have things called filter strips, and those are areas of grass which are particularly designed to actually clean the water by allowing the silts and sediments that collect in runoff from roads to be cleaned out of it before it moves to somewhere else, as I was telling you before about what we did at the MSA. And then that might go downhill and come into what we would call a detention basin. So it's an area that fills up with water during a rainfall or after a rainfall event, and then slowly dissipates either by soaking into the ground or perhaps by evaporation. So, or indeed into flow. And then, so you've got that one, which is a detention basin, which ends up being dry. And then further down the system, we've got what would be called a retention basin, which is in essence a pond. And again, all of those will have potential to evapotranspirate when the sun comes out. Or again, there may be excess flows which go down to a stream and then, as I say, outwards and on to sea. So it's a big network that you've got as to how and where water flows and the different ways that it will do so based on where it's falling and what's around it. But if you take it into the urban environment, we have many fewer opportunities to actually allow that to happen because of the hard surfaces of the pavings, the roads, and the buildings themselves. And interestingly, you know, if you go to some of our big cities, there are an awful lot of roof gardens out there now, which have green roofs on them. And those may be inhabited ones where people who live in those buildings can actually use that as a social and environmental space, or they may just be that they have a green roof where those who've developed that or redeveloped that building put a green roof on it. Or you can have a thing called a blue roof. A green roof is what it sounds like it is. It has vegetation on that roof, and you'd be surprised at how shallow that has to be. I've seen some green roofs where they're little more than probably only about 12 to 15 centimeters deep, so that they're not that deep and not that heavy. But obviously, if they're holding water, then it's the water that becomes the heavy aspect of it. Obviously, you can, if you've built something new, then you can that can be designed into it. And one of the interesting things is that buildings with green roofs on them, it actually modifies the internal temperature of that building for the first couple of floors because of the cooling that it gives to that building. So plants can do some interesting things as well. So we have to convert what we do with nature in the urban environment through the series of SuDS interventions, really. You know, so if we can have green roofs or brown roofs or blue roofs is just like a little mini swimming pool, or what we're going to do on the ground. And that's where we start to use things like our swales and bioretention planters, as we call them, because we're still trying to get that same effect, but clearly it's more difficult to do in the urban environment. So there's like three levels that we try to get sort of drainage techniques used in series. And the reason we want to do that is because it helps improve the quality of the water as it goes down the system. So there's things called source control, which is where you're managing water as close as possible to where it falls on the ground. That may then get collected up and be managed through another system, which we would call a site control. And then whatever isn't managed through that will be connected potentially, say, into a road, and therefore that, or a stream, and that will then discharge into some bigger feature, which will be some form of regional control. So it's this connected network. And so if you look at it in a plan form, you'll see that what you've got is lots of small features that are connected up to middle-sized features, to bigger features, and then into a main feature. So it's like this big network that you get when you start doing things comprehensively. But clearly doing this is only reasonably simple to do if you're doing new build. It's really quite challenging where we're trying to do anything extensively as a retrofit. But if you then take that to a small development site level, then this is what looks like a really complex system, but actually isn't, because obviously we all have to have pipes conveying rainwater around our roads and things as it is. It's just we're doing it in a different way because we're using green systems as much as we can to be those conveyance mechanisms and to actually clean that water, and indeed hold a big percentage of it back in terms of soaking into the soil and the fact that we get the evapotranspiration when it stops raining, and some of it will retain for perhaps a 24-hour period, allowing it to discharge slowly off site. And it's that discharging slowly off site or soaking into the ground, which is what prevents flooding, because it's reducing dramatically the amount of water that goes off site at all. So before we invented SuDS, or before SuDS were invented, the only thing that we could do was to intercept the water and to do things like rainwater harvesting, so collecting it for reuse within the site. But once we started, SuDS became into the system, then we got a whole different range of what we call components, SuDS components, that can do that job for us and much more effectively. So the ones that we have and work with are, if you could have a blue roof, as I say, that's basically having a swimming pool on the roof, or a green roof where we've got planting up there. Infiltration systems, so that's systems that encourage water to infiltrate into the ground, but will hold it to enable it to have time to do so. We'll have things called filter strips and filter drains. They're really just areas of grass, and those are really just to the filter strips, that's taking out the silts and sediments, so that's cleaning the water. And the filter drain will not only do that, but it will allow the water to soak through. Swales are like, they're linear features, and they can be as wide as you like or not. And they will, they convey water. It's like a water channel, and you can have them, generally they will dry out once it stopped raining, but this is quite a, it's got quite a sharp size. This is a swale that you're seeing on this image here, and it's just this little line of rather nice planting that gets very damp and a bit soggy when it rains, and then the water goes away. But that's taking water from the car park. There's a car park to the left, and at the next level down there's a car park, as you can see on the right hand side, and the water from that car park goes to the next one down. Fire retention planters, those are planters, but they're in the ground planters, and those are the sorts of ones that you tend to see if you along streets in the main, because they're contained systems, and they'll probably take up a little bit of the footpath and a little bit of the road, and the water will flow into those. And then the water soaks down through that and then goes into a pipe network. But again, it gets cleaned, and hopefully you've got nice planting in it, and it slows the flow. So again, that's its contribution. Trees themselves are very good at holding water and retaining it, and indeed soaking it up. So if you had a nice long swale, you could plant the tree on the edge of your swale, and that would assist it even more. But just naturally, they soak up water. So the more trees we get, the more water the trees themselves will soak up that water and be very helpful. A detention basin is one where you're going to hold water temporarily on the scheme. So it might be just a depression, it might be within grass, or it might be something in a hard surface where it's held back temporarily, and then it's slowly allowed to discharge over a period of time. So again, reducing the amount of water in the system. Ponds and lakes, well, you all know what they are, and they're good for providing capacity. I have to say that the one I really prefer is wetlands, where we can do them, because although they don't dry out completely, but they tend to be damp, but they are wonderfully biodiverse systems if you get once you get one established. So not only do you get water quality improvements, but you get massive biodiversity benefits, which are attractive in a very different way to a pond or a lake. But it's about context. And if you're in a formal park, then you probably want a pond or a lake. But if you were somewhere where it wasn't so managed, then wetlands really are fantastic features. And again, they will hold and clean the water and be amazingly biodiverse. And then we get to the hard stuff, pervious paving. But again, on your drive, why haven't you got permeable paving, which again will clean the water, slow it down, and of course some of it will never go because it will just wet the how those suds have been constructed, and then eventually dry out as it after the rainfall's gone. take a while, but it will do eventually. And then, of course, something as we talking about planting and other things, there are these formal systems that we also do need those in some circumstances. But if we can do it through green systems, then obviously we will. But certainly in cities, there needs to be much more of this because it's about capacity, which we don't have at the moment. And so, some examples of how not to do it. This is just really unfortunate and poor examples. And what's wrong with them? Well, if you've got to fence it off, all I can say is you got it wrong. Because the reason that people fence it off is because what they've designed is in essence dangerous. And there is nothing inside that should ever be considered to be dangerous, because the design requirements say that the sides of the banks on the sides should be no greater than 1 in 3. And they should also have shelves within it so that if anybody got in there, they could easily get out. Now, if you look at that one on the left, that's probably, some of it looks like it could be getting on for, heading towards 1 in 1, and certainly at least 1 in 2. And so the maximum you want to see is 1 in 3, and you want to see it topped and tailed. So at the top of the bank and down at the bottom where your watercourse is going to be, you want to have it shallowed out so that you get a much more gentle profile. So that's got sharp profiles. They're no doubt scorching the earth with the mowers when they do mow it along there, because it's got quite a sharp angle of change, and they can't get right down to the bottom very easily because, again, it's going sharply into the water that's there. The one on the right is just appalling. They've had to put all sorts of fencing and metalwork around it because it is demonstrably dangerous, and that's exactly what no one should ever design to do so, as there's many other ways to do it. And then the one at the bottom, that is actually a bit of a cheat, I think, that one. Maybe not. No, that one, that's, again, terrible. Nearly vertical sides, pipes poking in from all directions. And again, we've got some fencing around it because nobody wants this anywhere near their back garden or indeed where they live. So this is some of the things that has then caused people to say, well, we don't like them, they're ugly and they're dangerous. Well, that's because they should never have been done like this. And that was, I think, lack of knowledge, particularly in the early days, or people who didn't have proper understanding and doing something and thinking it was a good way to sort out their issues without really understanding how to do it properly. But we don't see things like this now, but we used to see things like this years ago. I'm glad to say that we don't really any longer. They may not be perfect now, but they're an awful lot better than these. So really just to explain to you what the different sorts of SuDS components are, and it will be very, very quick, and we'll come back to this next time. And I won't be able to show you my video, so you have to come back next time because the video is a bit of fun as well. But just very quickly to finish off, I'll just talk you through the different SuDS components, and you can see how diverse they are. So top left, there we go. That's a green roof for you, where we've got quite a biodiverse green roof on top of a building. And below that, that's a type of swale, as is the one on the right. And you couldn't think of two schemes that were more different. So on the left, we've got a very naturalistic feature. It's got a little sort of wet pondy bit in the near distance, and then lots of rock and planting and things. And it's actually got some level changes, which you can't see terribly well, but where you've got a sort of white section across in the middle distance, that's a level change where the rocks drop down, and then you've got more capacity in the area beyond. So something that's designed as an attractive feature adjacent to this building, but nice to look out at, nice to walk past, or to sit around in your lunch break, and doing a really great job in terms of cleaning and managing the water. And on the right, a really simple system. This is abroad and I can't remember where it is, but very, very simple, but a very effective system. and getting double lots of water quality with the grass, and then going through the grasses, and then going into the gravel areas, and then that water gradually being collected. And you can see there's a little drain in that as well. And the top one is quite strange. I've never quite worked out what it is and why those trees are sitting down into that great hole. I'm sure there's a logic about it that I don't understand that must be there, but I think it may be, I don't really know how that one works, but clearly water is coming in from, you can see there's a gap by where the pebbles are in that bank. So I think that's collecting water inside that sort of tank type system, which is a slightly odd design, but yeah, novel. So again, we've got some more components looking at the small scale. So again, that's the type of swale, top left, but again, designed as a more naturalistic feature. Then we're getting onto our, and on the right, we've two systems here. You can see the one on the right. So we've got a channel, and we've got, and then two systems either side. We've got planting, but those are actually shallow ponds which have got vegetation growing in them permanently. So we've got the channel that's bringing the water from elsewhere, and then it's discharging it to both sides of the water system before taking it elsewhere. So the cleanliness is happening as it goes through those green systems. And then the bottom left, that's obviously, it's very straightforward. That's a pond, but it's one that's got capacity. So the levels of that will go up and down depending on whether it's rained or not. And the water will be collected there and held there and slowly discharged. And on the right, what you can't see is that the path through the middle is actually raised up. And if you look at the grass on the bottom right, you can see some sort of what looks like creamy coloured bits. So this is much lower. So they're growing natural vegetation there. And this area, if it has a very extreme rainfall event, all the water from those buildings and the roads beyond comes into this area. And it actually, quite a lot of it gets covered in water, but because it's a big system and there's buildings behind that are also sending water in this direction. But they've turned something out of a really pleasant walk, whether it's wet or dry, something that looks attractive and different, but is also managing water at the same time. So the whole point about them is, with these is that with SuDS, you get an incremental effect, but an immediate effect in what they're doing in terms of managing water. And the more interventions you have, then you can just build greater resilience. And the good thing is that we can do them incrementally to actually get greater effects once you start working on these systems. And, they're flexible because you can basically design anything you like. And as long as the way it's put together is correct, they're going to deliver what you need. And that interesting, that term value for money, we've always said that, but those against SuDS always say they're expensive. Well, they can be expensive if you design them in an expensive way, but actually, using plants is a really cost-effective way, I think, to doing it. So, but to do that, you've got to develop this mindset that thinks about how can I do this through SuDS first of all? And it's only when you've considered all those options, if you can't get them to work or can only do some of it, then you may have to consider something more conventional. But, you've got to have that mindset and then consider how you can then apply that wherever you've got the opportunity to do so. And in an ideal world, if they're digging up the road to do something or other planned works that are happening, improvements, environmental improvements, get it integrated in those plans, because the budgets for those issues will be so much more than what the SuDS costs, that actually adding those in won't change those costs by much, but it will change the environment hugely if they're well done. So as I say, align it with other objectives, particularly around public health, green infrastructure, the biodiversity it can deliver, and obviously, water quality improvements and placemaking, just making places nicer places to be. So the mantra with that is we need to do it all the time, everywhere. And as you can see, in America, they've well exceeded the 56,000 downspouts that there were 15 years ago. They've probably doubled that number. So I think, based on the time, we will stop there, unless anybody would like to ask me any questions.